Good evening, everyone. It's my great pleasure to introduce Dr. Jeremy Shears this evening, the director of the BAA Variable Star section. This is the fourth Wednesday webinar for the British Astronomical Association, and the title of tonight's topic is Two Variable Stars in the Northern Crown. I'll just pass over to Jeremy.
Excellent, thank you, Andy, and welcome everybody to my observatory here in Cheshire on this absolutely wonderful spring evening. I'm certainly looking forward to going outside in 2 or 3 hours to do some observing. I hope it stays like this. Just before I start the presentation, I'd like to thank Andy. He's really done an excellent job in organising, getting up and running these webinars, and it's good to see the feedback we've had so far. I'll try my best to keep it going tonight. I must say that I actually approached this webinar with some trepidation. The director of the comet section recently spoke about the prospects of one of the comets that's currently in the night sky, Atlas Y4, shortly after which it disintegrated. And then the week later, the director of the equipment and techniques section spoke about imaging Venus. And that seemed to cause his camera's power supply to fail after 15 years of reliable service. So I asked myself, what could possibly go wrong this evening? So with that, what am I going to cover this evening? During the webinar, I'd like to cover a few aspects of variable star observing. I want to start off by talking about, well, why observe variable stars? What's so interesting about them? And in that, I'll touch on a little bit about what sort of equipment you need to observe variable stars. But for the most of the time, I want to introduce you to two variable stars that you might like to observe, not only tonight, but through the rest of the spring and into the summer and autumn. After I've spoken, we'll open the line for questions, and I'm delighted to say that I'm going to be joined by two other panelists for the question session. Gary Poyner is going to be joining from Birmingham, and Andy Wilson is joining from Bristol. So variable stars. Well, I think the first thing to say is that many stars in the sky are variable. Even our sun, of course, is slightly variable. But happily, it's not variable as some of the ones as variable as some of the ones that I'm going to talk about tonight, because that would cause catastrophic effects on the Earth. So we're very lucky that the sun is only a minor variable. So I like to show this slide that's on the screen at the moment, because what it should be showing, although it doesn't seem to be in mine, is there are a number of those stars varying. So we're still on the previous slide, Andy. The picture of the globular cluster, there we are. It probably froze after a while. You can see many of those stars in the globular are varying. Of course, this is a time-lapse image that has been speeded up. And I like to point out that these cluster variables, as they're now called, were first discovered in the globular star cluster M5 by a BAA member many years ago, David Packer of Birmingham, more than a century and a quarter ago. So there's a link to the BAA there. So if we go on to the next slide, let's start thinking about why observe variable stars. And I'd say that for many of us, and that's myself included, there's much pleasure to be gained from watching a star night after night, seeing its brightness change and wondering about the reasons that may be causing that change. And in doing so, some of those stars become old friends. And like old friends, it's interesting to see how they are. I go out each night trying to see if they've changed, if some of them are up, if some of them are down, or what on earth's going on. So that's a bit of a subjective reason. There are, of course, scientific reasons for observing the variables, and why collection of large amounts of data is an important and indeed a useful activity. Research on these stars provides a wealth of information about stellar properties. Some of them are listed here: mass, radius, luminosity, how evolved the star is, what its temperature is, even about the composition of the star. And some stars vary very slowly, and you need to observe it over decades to see that variation. On the other hand, others, their brightness varies within a few minutes or even a few seconds. So there's a lot of variety out there. Now, for me at least, variable star observing becomes even more rewarding when professional astronomers request the data, so the fruits of our labor that we've collected over many nights, perhaps over many years. And from those data, they're able to deduce snippets of information about the system, about the star that we alone have monitored. And in fact, it may be that an important observation of that particular star may be made by just one observer on that particular night at that specific time. Now, I think it's fair to say that professionals really don't have the time to monitor many variable stars continuously, and they don't have access to telescopes continuously. So if a star begins to exhibit unusual behavior, the amateurs can alert the professionals to the changes, and that can result in allocation of telescope time for more detailed observations by world-class telescopes, or even satellites to point in the direction of the variable star. And it's sometimes the case that data can be correlated between what professionals observing with their telescopes and what the amateurs are doing. And frequently I'm approached by professionals to say, can you organize the amateurs to make follow-up observations while we're making our observations? Let's go into the second slide, because I want to start with an example, so a recent example. And it's not often that variable stars are featured in the main news programs, but they did back in December, as you probably remembered, when it was found that the bright star in Orion, Betelgeuse, was undergoing a fade. And there was a lot of speculation which led to the news stories that it might about to go supernova. Now, Betelgeuse, as we know, is a red supergiant, and it's nearing the end of its life, and it's therefore possible that it will go supernova at some stage in the next, 100,000 years or so. But that's not connected to the recent fade. Betelgeuse is, of course, easily recognizable in Orion. It's the top right, the right shoulder of Orion, and it's normally one of the top 10 brightest stars in the sky. But last October, it began to get dimmer, and it gradually faded. And by mid-February, it's lost more than 2/3 of its brilliance, as shown in this animation in the top left by Tim Weatherall of Somerset. So visual observers saw the star fade from a magnitude of about 1/2, so a really bright star, to around magnitude 1.7 in February. And you can see that fade in this light curve, which comes from the variable star section database. It shows the brightness on the left-hand axis, the y-axis, and the date on the x-axis. It's now almost back to normal brightness, although we're about to lose it from view. It's getting very low in the west in the evening. So we know that Betelgeuse is a pulsating star, and as it pulsates, it varies in brightness. And there's several periods over which it pulsates. There's probably a 400-day period and a 6-day period, and it seems to occur from time to time that the minimums of these various fade cycles line up, and that's when you see the fade. But there's another piece of information, and that came from the Very Large Telescope in Chile on the top right, which showed that there was an unusual darkening of Betelgeuse, which seems to be associated with large dust grains, and they might have contributed to the fading. So if we go on to the next slide, let's talk about some of the equipment that you need. And I think one of the beauties of variable star observing is that you can use whatever kit you already have, even if that's the naked eye, as we've just seen with Betelgeuse. It was amateur naked eye observations that enabled professionals to really begin to answer the questions that were posed by the fading. Binoculars provide a lifetime opportunity with variables, many are available, and of course a small telescope even more. There are basically two kinds of observing. One is visual observing, say with binoculars, where you compare the brightness of a star with other stars of known brightness in the same field. And another example is photometry, where you either use a CCD camera or perhaps a DSLR digital camera. And here you take an image with one of those cameras and you use software to work out what the brightness of the variable star is. Tonight I'm going to focus on visual astronomy. Many other ways you can get involved in variable star astronomy. Some people use remote telescopes over the internet. Others do spectroscopic observations, and even some people, when it's cloudy, like to analyze the data that amateurs have gleaned over the years. So we move on to the next slide. The thing I want to stress here is that variable star observers tend to observe alone in their back gardens. That's the nature of the beast. But in reality, it's a team sport. And again, I'd like to illustrate this with this plot from the variable star section database. Again, there's the brightness of the star on the left-hand side. So the top of the axis, it's brighter, and at the bottom of the axis, it's fainter. And on the y-axis, you can see the date from the 1st of January 2000 up until near the present time. The more observers, the better quality of data and the better light curve you get as a result. The issue is that for many of us as individuals, we can't observe all the time every night. It's cloudy sometimes, we have work commitments, other commitments. So take this example of the light curve showing observations from Sean or Brighton. Interesting data plot there. Moving on to the next slide, if we add just one more observer, and in this case, we add Mike Gainsford's observations to Sean's, we immediately see more detail in the light curve. We begin to see actually what's going on here, but still there are sections missing. So we need to add some more, as shown in the next slide. If we add another 53 observers, we get to see what is an extraordinarily complex light curve, and dare I say an exquisite light curve. And it's the light curve of the first star in the Northern Crown I'm going to talk about this evening, which is our Corona Borealis. Now, our Corona Borealis is characterized by these dramatic and unpredictable fades, which occur within a few days or a few weeks. And sometimes the star gets as faint as 15th magnitude. And over subsequent weeks or months, the star re-brightens to the limit of naked eye visibility at around the 6th magnitude. And you can see in the plot here, in 2007, the star faded a full 8 magnitudes. And that occurred in only 33 days. And it was faint for a number of years after that. There were a couple of dips and rises, but it's almost recovered now, bar for a fade last year that you can just see at the right hand of the plot there. So what on earth's going on here? Let's think about what's going on if we look at the next slide. Our Corona Borealis has been a favourite with observers ever since it was discovered in 1795 by Edward Pigott, who was observing from Bath. I say that's the city of Bath. He wasn't in his bath. It's not something I would recommend for observing variable stars. We now know that our Corona Borealis is a yellow star. It's a giant star. It's about 100 times bigger than the Sun. And it's what astronomers call a highly evolved star. It's been around a bit, shall we say. And compared to the average star, it's unusually poor in hydrogen. There's only about 1% of the matter is hydrogen, but the vast majority is helium, about 90%. But the key is that it's rich in heavier elements, including carbon and nitrogen, as well as some molecules like cyanogen. And it's thought that these fades are caused by condensation of carbon soot, effectively, which puffs out into space from the star. And it's the soot that makes the star fade in invisible light. If you look in other wavelengths, in infrared, for example, there's no fade because the energy can go through the carbon soot. Eventually, after days, weeks, months, and in some cases a decade, the dust eventually disperses, and that exposes the photosphere of the star once again. There's been an animation running, I think it's stopped now, by Rowan Carrow, which shows these sooty deposits being pushed out from the star. And our Corona Borealis is the archetype of a very select family of stars that bear its name, our Corona Borealis stars. And there are only about 150 of these known in the galaxy. So it's well worth keeping an eye on our Corona Borealis. So let's, in the next slide, talk about how you can observe it. Fortunately, it's quite an easy star to find. And this chart here shows the sky as you might see it if you went out at 11 o'clock this evening. To locate the constellation of Corona Borealis, you need to find the star Arcturus. So follow the curve of the handle of the plough round until you find Arcturus. And that's the main star in the constellation of Bootes, which to me looks like a kite lying on its side. And the circlet of the northern crown is nestled just below it. And the next slide shows an enlarged version of the northern crown, with R lying almost in the centre of that little circlet. It's currently just below naked eye visibility, easily seen with a small pair of binoculars, and yet when it goes into one of these fades, you'll need really quite a large telescope to find it. So now is a good time to spot it. If we go to the next slide, if you wish to estimate the brightness of the variable, you can download a chart from the Variable Star Section website. And this shows the stars that make up the northern crown, plus some fainter ones that you'll see in your binoculars. The location of R is shown in the center there with that little circle with a dot in it. And it shows the brightness of some of the neighboring stars that you can compare it with. And last night I was observing R in my 8x42 binoculars, and I had it slightly fainter than the star E marked on this chart. Whereas curiously, the night before, only 24 hours before, it was a little bit brighter than that star. And this suggests that it had faded from magnitude 6.4 to 6.6 in those intervening 24 hours. Now that might be just a blip in the light curve. We know that the star shows shorter term variations, or you never know, it might just be the start of a fade. And the only way we're going to find that out is go out in 2 or 3 hours and look up at it and see how bright R is. And it's certainly worth keeping an eye on, because we've no idea when that next fading event will occur. If you move on to the next slide, I show an animation here of a photograph taken by Greg Parker from his New Forest Observatory. There are 2 images being blinked. One is in 2013 and one is in 2015. And in one, the star is very faint at about the 14th magnitude, and then in the other one is brighter, and you can see it peeping out very strongly at 8th magnitude. And as you can see, it's quite a photogenic field. So let's move on. If we now look at another famous star in Corona Borealis, this time the star known as T. So T Corona Borealis is a very different kind of star, and there you can see it marked on the star just outside that circlet of the crown. Now normally, and certainly last night, the star slumbers at around 10th magnitude, but back in May 1866, it was spotted by John Birmingham, a resident of Tuam in Galway in Ireland, as a new star, a bright new star or nova in the night sky. And its brightness was magnitude 2, so it was easily visible to the naked eye, and it outshone the brightest star in Corona, which is called Alphecca. But it faded back very quickly. And John Birmingham had only taken up astronomy comparatively few years before this, but this discovery really spurred him on in his hobby, and he was able to get a small telescope, and he became a very well-known and respected observer of red stars. So moving on to the next slide, the story didn't end there. Yes, the star faded back, but 80 years later, on the morning of the 9th of February 1946, the nova sprang back into life. And it was discovered completely independently by 2 observers on each side of the Atlantic. The first was actually a BAA member, Norman Knight of Bedford Park in London, but only 10 minutes later, it was also spotted by Armin Deutsch, who was a graduate student at the Yerkes Observatory. And it's certainly true that Armin Deutsch didn't need the 40-inch refractor to see that telescope, because it was shining back through his binoculars that morning at magnitude 3. There's a strong link between T Corona Borealis and the American variable star observer and comet discoverer Leslie Peltier, because he observed T Corona Borealis very faithfully for 25 years, trying to catch this catch an outburst. But on that fateful morning in February 1946, he'd set his alarm for 2:30. It went off, and he was planning to observe some variables in the pre-dawn sky. But when he awoke, he went to the window, drew back the curtain, felt a little bit of a tickle in his throat and perhaps a sneeze, and thought, well, he owed it to himself and his family to go back to bed. And that was a big mistake, of course. For that, it was that very morning that T Corona Borealis came back to life. And I know I felt like that on cold winter's mornings. Got up, but maybe go back to bed. I wonder what I've missed. Leslie Peltier describes in his autobiography Starlight Nights how he continued to monitor T for effectively the rest of his life, but it was always with a very wary eye. If you haven't read this book, this autobiography, I really do encourage you to read it. I've recently reread it. I read it about once a year because it describes his love of the night sky and his love of the variable stars. And there are passages in that really resonate at the moment, because he talks about winters when he was stuck in his farmhouse in Ohio, and also years during the Great Depression when life withdrew and slowed down, and yet he had the variable stars to resort to. So it's a timely read at the moment. If we go to the next slide, thinking about T Corona Borealis, what it's made up of, well, like all novae, it's actually a binary star, and it's made up of a red giant star, and that's in a 227-day orbit around a really small star, so a planet-sized star that's called a white dwarf. And the white dwarf has a really strong magnetic field, and it's drawing material away from the red giant, and it forms this accretion disk around the white dwarf. And some of the material actually gets funneled down onto the surface of the white dwarf. And there, with time, it gets compacted, and as a result of that, it gets heated, and eventually it ignites in a thermonuclear explosion, as we'll see on the next slide. And it's that that we see, if we move to the next slide, that results in a sudden brightening of the star. Andy, can we move on to the next slide, maybe? Thank you. The animation's starting. So what the animation's showing is that the outer layers are blown away into space, and the gas ends up with what we now call a planetary nebula. But in that eruption, only a small proportion of the star's mass is lost. And that means that some novae, and possibly all novae, who knows, can repeat. Perhaps on time scales of thousands of years, so we'll never see them repeat, but others repeat more frequently, and there are 10 of these recurrent novae known in our galaxy. Just as an aside, there's recently, a couple of years ago, a recurrent nova discovered in the Andromeda galaxy. This is really faint, so you'll need a large telescope to see this, but it actually holds a record of the most frequently erupting nova. For it goes off about every year, and members of the variable star section have been monitoring that particular nova in M31 with professionals from the Liverpool John Moores University. That's a fascinating one to follow. So moving on to the next slide, another light curve. So it's worth bearing in mind that there was an 80-year gap between the previous two eruptions of T Corona Borealis. So So people have speculated that perhaps we're due for another one in the next few years. 2026 would obviously be the 80th anniversary. Now, after the 1946 eruption, the star pretty much stayed under the radar for the next 69 years, holding steadily at around 10th magnitude. But that began to change in February 2016, when it inched up slightly to magnitude 9.2. People got really excited at this point. You can see there's a little bit of a peak that's identified by the red arrow. That the brightness wasn't sustained, but nevertheless, it is still brighter in the last 4 years than it has been for many years before. And in addition to that brightening trend, the star has also become a little bit bluer. And this combined blueness and brighter state is what astronomers call a superactive state. And tantalizingly, this last happened in 1938, just 8 years before its last great eruption. So will T Corona Borealis erupt tonight? Has it already erupted? Has somebody else seen it further east from here? Who knows, but surely it's worth keeping an eye out for. At the moment, if you were to go out and look for it tonight, you'll need a small telescope, something like a 75mm telescope will be able to show you that. Again, you can get star charts from the variable star section websites. Now, when it does go off, and it will go off sometime in the next few years, I'm pretty sure, telescopes all around the world, but also in space, will be directed towards it. It'll be visible to the naked eye, but you won't have long. Based on the previous two eruptions, it'll only be naked eye brightness for about 5 or 6 days. So move to the next slide. And really what I've covered this evening are just a couple of examples of different types of variable stars. There are many out there, many different families, cousins, brothers and sisters of the ones I've talked about this evening. But if you'd like to know more about variable star observing, do go to the section's website. Should point out that the BAA variable star section is actually the oldest, the longest established organisation for observing the variables. It's been around since, as long as the association, in fact, since 1890. We have over 3.5 million observations in our database. We can provide all kinds of advice about which variables to observe, depending on the equipment that you have. We have a mentoring scheme if you need help in starting observing, or we can supply the charts where you can download those from the website. And every 3 months we publish a circular, and I'll just give a plug for the current circular. If you haven't seen it yet, do download it free of charge from the association's website. It has a fascinating article by Mark Kidger about the recent fading event of Betelgeuse. Really well written, and thanks to Mark for producing that. I thoroughly commend that to everyone. From time to time, we also organise observing campaigns on specific variable stars, and we organise meetings. There was supposed to be one in a couple of weeks, but obviously with COVID-19, that has been postponed. So moving to the final slide, I hope you've enjoyed hearing about these two very different variable stars in the Northern Crown. Maybe, just maybe, it's encouraged you to go out and have a look, check out what R is doing. Has it faded a bit more since last night, or is it back to where it was the night before? Has T gone over? Who knows? With that, I'll stop. Thank you for listening, and I'll open for questions and answers.
Thank you, Jeremy. Unfortunately, I have an emergency at this end, so I won't be able to join the Q&A, but I will just unmute Gary to allow him to talk. I hope that's okay, Gary. And Gary will now be able to mute and unmute himself.
Gary, can you hear us?
Yeah, can hear you, Jeremy.
Excellent.
And Jeremy,
yes.
And also the best way to do this is going to be if people can submit the Q&A, which they'll find at the bottom of the screen, and they can type in questions. Unfortunately, I've got to leave the computer, and I'll come back in a little while, but I'm unlikely to be able to participate in the rest of the call. But I'll leave everything running here if you can I don't know, Jeremy, can you see the Q&A from your end?
Yeah. They've just come
Okay.
up. There are a couple of questions that have come up. So thanks, guys. Enjoying the webinar. Yeah, a couple of questions. This is from Mike Foyler. Hi, Mike. What filters are recommended? Well, depends what kind of observations you're making, Mike. If you're making visual observations, no filters, visual observations with your eye through the telescope, naked eye, binoculars, that's fine. I guess you're really talking about what filters you would use with a CCD camera. One filter that is recommended is called a visual filter or a V-band filter. If you look at it with the eye, it's a green filter. And the reason for that is that it is closely correlated with the brightness you would measure by, or a visual observer would measure. You can get other colored filters with other bands. It really depends what kind of star you're observing. There's a whole load of other stars that you don't need a filter for at all. My particular work is to observe cataclysmic variable stars, where a filter isn't needed. One of the reasons why a filter is recommended is that it helps you to standardize observations between different observers with different telescopes, different cameras, and therefore you can get a proper comparative magnitude, a consistent magnitude between observers. But in the kind of stars that I observe, the actual magnitude doesn't matter too much. It's more to do with how quickly those variations are concerned, and hence you don't really need a filter for those. I could probably give a whole webinar on filters, so I'll move on to the next question, which is what software is recommended for photometrically reducing variable stars. Again, there are a whole host of these available, are available. I use one called AIP for Windows, AIP for Win. There's other ones. AstroImage J is very popular, but again, there's some information on the BAA website. It's either commercially available software or stuff that you buy at a relatively low cost. The next question from Simon Street. Any good circumpolar variables to observe from the UK? And I guess we're talking about visual observations here. Gary, circumpolar, what would you recommend for?
Well, certainly with a small telescope or a pair of binoculars, Enuma is the star that I would recommend. It ranges from about magnitude 6.8 to about magnitude 10. It's currently just below magnitude 7. So an observation every 4 or 5 nights over the coming weeks will show this star fading slowly. It's circumpolar, and at the moment it's very well placed in the evening sky. So I would definitely recommend Enuma.
And presumably that one is also on the variable star section website to get the chart.
Yes, absolutely. Yeah, there's a chart on the web pages.
Excellent. So I hope that that helps, Simon. Next question's from Alan White. Hi, Alan. Is a 4-inch refractor suitable for visual use and variable star observing? Absolutely. You can have several lifetimes observing with a 4-inch refractor as a visual observer. As I say, last night I was using 42mm binoculars. I also have a 4-inch refractor. I've used that extensively, mainly for CCD observing, I must say. But absolutely, Alan, it sounds an ideal instrument to be able to use. James Dawson's asking a question: what is the shortest period variable amateurs can observe and see a noticeable fluctuation in brightness? Gary, what do you think about that?
Okay, so I think we're obviously going to talk about an eclipse star here.
Mm-hmm.
Naked eye, Algol, you can follow that for a couple of nights. There are lots of eclipsing binary stars on the BAA program. If you've got a telescope, the thing to do would be to look for an eclipsing cataclysmic variable in outburst. You can see over 2 magnitude change in 20, 25 minutes with one of those. So you need to keep abreast of what's going on in the CV world. And if that's the type of thing you're after, then look for something like that.
Yep, that's a good suggestion. Lots of eclipsing binaries you can observe. Just moving down. DSLR observations. What frequency would you use to take images for these stars? Would you stack several images or treat each image as an individual estimate? And with my 6-inch Newtonian, some details about the instrumentation. So the frequency for taking images depends on what you're trying to observe. With the stars that Gary was just talking about, these eclipsing binaries that change within 20 minutes, you'd obviously want to be taking an image as often as you can, every few seconds, perhaps every half minute, every minute. And then building up a light curve from that. If it's a much more slowly changing star, you might only want to observe it every few nights. You might want to take a number of images, say tonight, and then come back at the weekend and take another series of images. And yes, it's often better to take several images, not necessarily stack them, but work out the brightness in each of the images, and that gives you an indication of the statistics associated with your observation technique. I did see another question somewhere else that was related to that, which I think is worth talking about, and I'll maybe ask Gary to mention it. Frequency of observation. Let's set aside DSLR observations. Gary, can you? People often ask me, for different types of stars, how often should they observe? Can you give us some guidance?
Okay, so if you're just starting out and you've got a handful of stars that you want to observe, you need to do a bit of research first. So check in the catalogues to see what period the stars are. Now, something like a pulsating star, a Mira star, for example, would go through a complete phase in perhaps 250, 300 days. So there's little point in observing that every night. Once every 7 to 10 days, and you'll have a good light curve at the end of it. Cataclysmic variables, of course, and stars like our Corona Borealis, they can change in hours, not weeks. So you would observe those stars every single night. And something like SS Sig or UGEM, which are the two of the brightest cataclysmic stars, dwarf novae, if you detect one of those that's brightening, then you would probably make an observation of that every hour throughout the evening. And by the end of the night, you should be able to see the star rising by more than a magnitude. They do move that quick. So you really do need to do a little bit of research first and to see the period of the star. Anything less than 200 days, you observe every 5 days. Anything longer than 200 days, you would observe a week to 10 days. CVs and eruptive stars every night.
Yep, thanks for that. Thanks for that, Gary. A question here from Pete Sherman. Is there a way to rate the magnitude of a variable dependent on weather conditions, poor seeing, light cloud, for example? Gary, can you lead us through the how you report this
the thing to do about that is not to worry about it. If you're looking at a variable star through an orbit of a telescope, then the comparison star will be very close to it. So anything that's affecting the visibility of the star, the transparency, the seeing, it will affect the comparison star as well. So don't get worrying about the seeing conditions when you're making the observation. Just make the observation as normal and carry on. The problem arises if you're observing naked eye stars like Betelgeuse, where the comparison stars might be 15, 20 degrees away. Then it might introduce some problems, but it's certainly nothing to worry about.
Very good. Thank you, Gary. Question here from Tim Milton. What's the difference between an R Lyrae variable, I think that's an RR Lyrae variable, and a Cepheid variable. Are there any of the latter that can be observed via small telescopes in the Northern Hemisphere? I'll let you think about if there are any Cepheids you'd recommend, Gary, while I answer the first bit, which is around Cepheids and RR Lyrae stars. So these are both families of stars that vary consistently. They show very interesting light curves. And of course, the Cepheid variables have been very important historically for working out the scale of the universe. They are cousins, if you like. They're first cousins of each other. The Cepheids tend to be less luminous, and they have shorter periods. And usually these are sort of 5 hours to a day. So they are bookends, if you like, of very similar variable stars. And the RR Lyrae stars are often found in star clusters. So Cepheid variables to observe, Delta Cephei maybe, or what would you recommend?
No, well, the only one I would recommend would be Delta Ceph.
Yeah.
The thing is, it's so well known that it's a good experiment to do if you've got a DSLR or a CCD. But they are very regular and very predictable. They don't make really exciting stars to observe, but they're good for an experiment. So I would recommend Delta Cephei, certainly.
Excellent. Yeah, very good. This is an interesting one. Mark Tredici. Hi, Mark. He says he was chuffed to see his name in that list of 53 observers of our Corona Borealis. He made these observations with his 100mm binoculars, and good that you saw that Mark. And thanks for your observations. It really does show you just what is in our database. You know, we go out there night after night making these observations. Sometimes it's blimmin' cold, sometimes we're uncomfortable. We think, well, why are we doing this? But of course, your data are then combined with others, and they do turn out to be really useful. So he has a question following on from that, which is are there any other recurrent novae that are followed? Yes, there are a few that are followed routinely. There's RS Ophiuchi. I'm trying to think when that last went into outburst. Do you remember, Gary? RS went off.
I'll tell you in a sec.
While you're checking that is one of them. One that I like.
2005.
2005. Okay. So that's one that's worth keeping an eye on. There's T Pixidus, but that's pretty far south. So if you're in the UK, it's almost it does rise, but it's really difficult to see. I remember Gary and I tried to see it from Winchester once when it was an outburst for a few years ago. Remember that, Gary?
I do. I remember climbing up a flagpole trying to see it.
Indeed, that was pretty uncomfortable, wasn't it? we didn't see it either.
No, we didn't.
Other recurrent novae, any that are on your list?
Yeah, there are a few, but they are quite faint. GK Per, I guess, would be the most famous. It was, of course, Nova Persei 1901, discovered by the Reverend Anderson. But since the 60s, it's been undergoing dwarf nova type outbursts. So every 3 years, it rises from about magnitude 13 up to magnitude 10, 10 and a half. So if you see an old nova active, then GK Per is the one to have a go at.
Yep, that's a good one I like. Is Andy back yet? Because there's a spectroscopy question that's waiting in the wings for some recommendations by Hugh Allen. So Hugh, I'll hold that until hopefully Andy will come back. But I understand you're speaking in a webinar soon, so I'm really looking forward to hearing from you about that. Mike Foylan again. what's your favorite variable star and why? I'll say my favorite, and then Gary can say his favorite. So my favorite, and again I was looking at it last night, is actually a very, very faint star, I have to say. It's one that you need a telescope to see, and preferably a CCD camera. It has a prosaic name. It's V452 in the constellation of Cassiopeia. And I like it for a couple of reasons. One is it's absolutely a beautiful field. It's sparkling with stars of various brightness across the field. So it always gives me joy when I see that. But secondly, it's a dwarf nova. It suddenly brightens by several magnitudes, and there are hundreds and thousands of dwarf novae around. But V452 Cas is one of the most frequently outbursting. It goes off about every month or so. So it's not long that you have to wait before you see it coming into outburst. So that's always fun. It's circumpolar as well, which also helps. Gary, what's your favourite?
Well, I don't even have to think about that. My favourite is an RCB star called DY Persei.
I thought you'd say that.
Yeah, it lies not far from the double cluster in Perseus, in a nice open cluster called Trumpler 2. And myself and the late Margareta Westland in Sweden first began observing this star in the early 1990s, when it was thought to be a minor pulsating star. And since then, I've made observations of it every night, and now it's a new type of subgroup of the RCB class. So it's a very special RCB star, and that's my favourite variable.
Yep, that's a really good one. I see John is commenting about a US situation. I wonder if that's John Isles. Anyway, John noted that he tried to observe T-Pix from a cemetery on a hill, but the police ejected us. That was in Massachusetts, USA. Fortunately, the Winchester authorities didn't eject us, did they, Gary? But
no, they certainly didn't.
They might well have done. There is a question about where do I find Dr. Mark Kidger's article on Betelgeuse? So that's in the current variable star section circular. So if you go to the BAA homepage and you look on the right, you can see the observing sections listed, and the variable star section is there. Click on that and it'll open up the variable star summary page, and on that page you'll see a link to the VSS Circulars archive, and there you can download all the circulars, which go back to 1st of March 1922, but you don't need to go back that far because it's a current circular 183 March 2020. Click on that and you can download a PDF. I don't know if he wants to know this, but he wants us to say this. But John O'Neill, thank you. I'm glad that you weren't arrested, but only ejected by the police from the cemetery in Massachusetts. You said you tried to observe it. I guess you were unsuccessful. Let me know if you were successful by typing something in. Steve Bosley seem to be talking about variation in luminosity. Are there any stars that vary visibly in colour? What do you think about that one, Gary?
I'd need to get my thinking cap on for that one. It's not something that bothers too much for the visual observer, but certainly if you want to see changing colour, then and you've got a small telescope or a pair of binoculars, then Mira stars are the ones to go for. Mm-hmm. You can see the stars definitely become redder as the brighter they get. In fact, it obviously loses that bright red hue. But if you want to see changing colour in stars, go for something with a large amplitude and it is a red star.
Very good. Oh yeah, John's continuing the saga of the ejection by the police from the cemetery in Massachusetts. No, he was ejected before he could make an estimate, unfortunately. T-Pix wasn't around for very long, was it? It was about three or 4 days, Gary, do you remember?
Yeah, it was very short outburst.
And as I said in the presentation, when Corona Borealis goes off, it'll be around for a similarly short length of time. I
think the interesting thing about T Corona, in 1946, 4 months after the outburst, it rose again to about magnitude 7.5. So it's had 2 outbursts. So that'd be something to look forward to.
Yes. Yep. Okay, another question. So it's related to the earlier question about somebody wanted to remember earlier talked about which circumpolar stars to observe. Somebody's asking, are there any other stars that you recommend me to have a look at tonight if it's clear? I'm not sure what instrumentation. Let's assume it's binoculars or a small telescope. What would you recommend tonight, Gary?
Well, circumpolar. I'm not a great.
Not circum. This one is just any star in the sky tonight.
Oh, any star. Well, certainly our corona is one to look for, especially if it might be fading. Mm-hmm. Look for Z Enuma as well. Mm-hmm. If you look at sky to the east, there's a couple of other RCB stars. DY Per, of course, which is low in the northeast, and SU Tauri, which is mentioned in not the last BAA journal, but the one before. That's still undergoing a long period fade. It's not quite back to maxima yet. So if you've got a small telescope, look for that.
Yep, very good. I'm just going to do another refresh to see whether there are any other questions coming in. No, I think we've covered all the questions. So it's probably time to wrap up now. First of all, thank you to Gary for joining. That was really helpful, Gary. Thanks for doing that. There are more webinars coming up in the coming week, as shown in the slide in front of you. This Friday we've got a special one. Dr. John Mason is going to be sharing special images for the 30th anniversary of the launch of the Hubble Space Telescope. I remember it being launched. It doesn't seem like 30 years ago to me. And then, of course, on Saturday, this Saturday, we have the BAA Spring webinar. So 2 talks there. Professor Simon Goodwin from Sheffield talking on Is There Anybody Out There? Which is a thought that was going through my mind sometimes this evening. It's difficult sitting by one's observatory thinking, can anybody hear me out there? And that will be followed by the director of the BAA Exoplanets division talking about, that's Roger Dimmock, of course, talking about exoplanets. And then this time next week, 29th, David Arditi, hopefully having repaired his power supply in observatory, will be back talking about a twilight tour of the moon. So with that, thank you everybody for joining this evening. I hope you found it useful. Please provide any feedback that we might find helpful, and look forward to meeting up on a future occasion. So good evening, everybody. Happy observing.